Welcome everybody to our ongoing series of AIM Sports webinars. Have been getting great feedback from a lot of folks. Just love to take a look at these. We got a good number of folks that always show up live, obviously, on Tuesday, morning here on the West Coast, just afternoon in the East Coast of the United States. But so many folks get a chance, like probably a lot of you that are watching this right now, watch it on YouTube, and I appreciate that, and I hope you continue to enjoy these, and we're just going to continue to find new and innovative things to talk about. And we've got some pretty good things planned moving forward. So thank you all for coming. We've been doing these for quite a while, and I think they're working out well for everybody. So I appreciate that you are all here. What we're going to talk about today, we're going to talk about optimizing bike gearing, and a couple of other small details we're going to share in the live chat. Some different links to the data that we're going to look at, to user profiles for it. This presentation is being shared over in the chat box. If you're here on YouTube later watching this non-live, if you just go down to the description box and open that up, there'll be a button there that says show more. Down there will be all the links that we talk about here. So if you hear me talk about a link into the chat box or somebody mentions it, all of those links and all of that sample data and all the stuff we're going to talk about is available for you to take a look at later as well. So keep that in mind. The optimizing bike gearing. We've been chatting about a bunch of different ways lately about mainly functions in Ray Studio 3. Ray Studio 3 a couple of months ago went production with its analysis package, and we'd been talking beta a lot before, and I really didn't want to focus a lot on the how-to things specifically with that until it came out in production. And when it came out in production, then we spent 6 or 7 webinars, and those will all be linked down below in the YouTube description, of where we went through every button that's in there, every function that you can open, and we talked about it for nearly the entire hour. Where, okay, this is what the button looks like, this is how it opens up the first time. Here's all of the options that are available to you, and here's some tips and tricks on how to use it. So we're not going to do a ton of that here today. We're starting down a whole nother road of doing some cool things where we're going to talk about more how to actually use the data, the analysis focus, and while that's always the fun part. So today we're lucky enough to have back Chloé from the motorcycle world, and she's going to talk about optimizing bike gearing. Some of that too, but also the overall visiting a track for the first time. It's going to be with a little bit of a focus on a bike, but we're going to talk about different things about visiting a track for the first time. One of the most important things on a bike is optimizing that gearing. So that's how we're going to focus on that. I'm just going to bring up this page a little bit and maybe turn it over to Chloé to talk a little bit. Let me share a couple of things. We've got to know Chloé here at AIM in the last year or so, and she's been using our stuff, and we started chatting back and forth, and she's even begun to go out and do some AIM trackside support at some of the different bike races, which we really appreciate. And I think, Chloé, you'll probably agree with me, since that's how I kind of started doing this as well. Boy, helping other people, there's nothing like teaching yourself like helping other people, and being as prepared as you can to help other people really takes your learning curve to another level, and you probably would agree with that too. So give us a little bit of background on you. We don't need to go through all those bullet points, but give us a little background on you and how you got to where you are here today sitting with us.
Sure. Well, I feel like I've already, in the past webinars, I've already gone over that a little bit, but a few things have actually changed since the last time we talked. So I still do race data analysis at Moto America. I have actually changed team. I work now for the team that last year won the Twins Class Championship, Twins Cup, which is called Robem Engineering. I've also started taking just the role of AIM trackside support. So now at every Moto America weekend, I just go from pit to pit, or I'm usually the main person that people come to whenever there is a broken solo or an issue with the software, just any question that people have. I tend to visit them and try to fix it as much as I can. I've actually also accepted a new job and started a new job since the last time we talked. So it's kind of, this one is kind of making a dream a reality. So I moved away from my job in research, and I'm now working as a powertrain engineer at Harley Davidson. And you can see in the picture on the bottom right, one of our race baggers. So we're actually racing the baggers at Road America this weekend, and I have a little part into this. I'm not part of the race team, but I get to do all the engine dyno testing for that engine. So it's really, really exciting and really cool.
Yeah, very.
And other than that, I've been in engines for a while, worked on engine dynos for a while, and started using AIM with an AIM Solo 2 DL maybe a couple years ago, 3 years ago now. And here I am.
And here you are. And it's your fourth time here.
Yes.
You've been with us 3 previous times. We'll link those videos in the chat box, and of course they'll be linked in the YouTube description. So some of the stuff that Chloe's going to chat with us today is building upon some things that that she has shared with us in the past. So keep that in mind, and we won't jump back too far and go into too much detail on some of those things. But so if you want a little bit more information, take a minute and go back and watch some of those. Those are pretty good. So okay, so as far as new track, new bike, right? You getting ready to go out and run. There's what we're going to focus on a little bit today is learning, right? Learning the bike, learning the track, learning the setup as quickly as possible. Talk a little bit about some things that you see now that you're out there, not only using the stuff on your own bike, but also then as a data engineer in a team, and then talking to all these people that are using AIM data and some of the hardware out there. How are they? What are some of the questions they get, and what are some of the suggestions you give them?
So, I mean, this slide is really about going to a new track where you've never been before, or going back to a track that you already know with a new bike. Because basically, if you have a new bike that's different class, for example, different CC, it's going to be, you're going to have to do this learning process again. So the main thing that we look at, or like the first thing that we actually get into whenever going to a new track is, first you have to learn the line, and second you have to set your gearing. So as far as question that people ask is, what do I need? Like, why do I need to get started in data? What do I need to start optimizing my setup? And this is just a general list of things that you should probably have in a box with you when you're going to a new track, especially if you want to race or if you're chasing time. So as far as the topic of this webinar, it's really good to have a set of front and rear sprockets. Usually, 4 different size rear sprocket, 2 sizes front sprocket. And as far as data analysis, you can do a lot with a Solo 2 DL. We've already talked about that in previous webinars, where you can do a lot with a Solo 2. But as far as gearing optimization, you do want to have a Solo 2 DL because you do want to be able to log RPM. And to log RPM, you either need to bring it as a speed channel, or you bring it through the ECU, and you need the Solo 2 DL at least. And then if you want to go the extra mile, which is also really, really good, you can have the potentiometers and you can have your brake pressure sensors. And in that case, you need to have something a little bit more advanced, like an MXM or an MXS 1.2, things like that.
A little bit is always good, but once you get that taste of some data, right, then all of a sudden, boy, if I only knew this, I could do even better. So then the suspension sensors come in, and some of the others. But that Solo DL, that is such a powerful tool on a bike, and we are so strong in our list of ECUs that Solo 2 DL will chat with and give you just many channels of data. So so I appreciate that. And then you do mention, just for a minute here, the extra bit of suspension, brake pressure sensors, but also cameras and smarty cams or other adventure cams, the GoPros and such. But that whole video thing is such a powerful tool that we've talked a lot about here. Just last week we had our webinar that was all about the introduction of the new SmartyCam 3 Sport model, which is just perfect for a bike as well, and will connect right to the Solo DL or any of the levels up from there.
The reason why I have the cameras here is not so much as far as choosing the right line or things like that, because you do see that in data. I like to use that, or I would like to use it in a way, because we don't have it at Mode America, it's not allowed. But I'd like to have it to kind of discard some of the laps that maybe we ran into traffic. Like if there is something that we're seeing on the data, somebody let off the gas too early, or had to slam on the brake at an area that's not really expected, you're able to confirm with the Smarty Cam or with any adventure cameras that you have that that person ran into traffic or there was a bump. Like it's really interesting to know what happened, and in that way you can actually not overthink that lab, throw it away, and move on to a new lab that actually has data that's of quality.
Yeah, we've had the saying here forever here at AIM. What happened, where did it happen, and why did it happen? Right, those three things, and there are a lot of sensor data in there that can help you. But boy, that camera being, especially now that it's tied in so tightly with Race Studio 3, that can answer a lot of questions for some people really quickly. So you don't have to dig into the data as deep as you might have in the past. So keep that in mind. I do see a question over there. I haven't read it yet, but if you have some questions for Chloe, make sure that you jump out of the chat box and into the question and answer box, and we'll bring those up. Either answer them in the background with some answers from some of our guys that are here, or we'll ask those later in the webinar. So I think I'd like to spend a little time right here. Just yes, you're going to talk about the writer inputs, but I also want to talk about the user profile and how you kind of set things up here a little bit for you to do the most efficient work that you can. Talk about that a little bit, but I will also share that this user profile is available if you're running a circle track car or a sports car or a bike or anything. It might be worth downloading this and taking some of her ideas and adjusting them to your channels. But Chloe, how do you set this up for the writer inputs? It's kind of an interesting screen.
Yeah, so this is really the main screen that I'm using as far as chatting with the writers and getting feedback from them and confirming what they're saying. I know that a lot of people in the motorcycle world are not using RS3 yet, so this is also a good forum if you have any questions on the functionalities. We also have a lot of other webinars that are touching on all the functions. But here I like to look at the GPS speed, which I actually like to have the GPS speed as a reference for everything. So we have the GPS speed. Right below it, we have the RPM. So you can compare, you can actually see your shifting points. Then we have the gear that we're in, our throttle position, which is actually the grip position here. We have, actually this one might be the hand. Yeah, this is the grip position. Our brake pressure and our lean angle. The lean angle is really important in a motorcycle because it tells you a lot about the available traction. It tells you a lot about, we're going to talk about it, but the wheel speed, and also it affects RPM. So
One of the things I'd like to jump in and point out that you do something a little bit different here than a lot of people do, and it's interesting, it's intriguing, and I think a lot of people may want to use it. It's this compiling right next to each other, putting the throttle position and the brake pressure one on top of each other, and then flipping the brake pressure, and showing that brake pressure as a continuous line coming down from the throttle. If the rider or driver, the pilot is comes off the throttle and gets right after the brake, this is going to be just basically a straight line right into the braking pressure. And then the same thing coming back up. If you start to see pauses in between there, we've got somebody that's coasting a little bit or not, or is pausing there at that with no brake or no throttle. I think it's pretty intriguing and looking at it. And is this something that you have used recently, or is it something you've been doing it this way for quite some time?
I've actually had it since the beginning. I think in the first webinar that I've done, I have it not so much as throttle position and brake pressure. I actually have it in positive linear acceleration and negative linear acceleration. But the reason why I do it like that, you can also have the brake pressure as positive, so just flip the right way. And it's usually for me to see where the persons are coasting. It's really nice to have it really close to each other. You could have it on the same graph as the throttle position. However, when you're adding another lap to compare, it becomes very crowded. So the fact that I have it right under like this as a continuous line really allows me to start just comparing like 2 to 3 laps, and it's still clear.
Yeah, I've just there are so many different people that they look at things different with different eyes, obviously, and I think it's just another option for folks that that maybe gives them even a more logical way of looking at it. So I think it's wonderful. We're by the way, we're going to go through another 4 or 5 slides talking about some things, and then we're going to go into live data, and we've got this exact data up and running, so we will take a look at it. And we will, Joe asked the question in the question and answer, how do we flip that data, flip this brake pressure? We'll jump in and I'll show you a quick, easy tool to do that. There are 2 or 3 ways of doing it, but I will show you how we did it in this particular data to give everybody an idea. So
Matt is asking something that I was about to touch on. One thing that I really, really like about RS3 is the way that you can color the maximums. So in RS2, you could only, whenever you would set it's not a maximum, it's a limit or a threshold. When you have the threshold, for example, in RPM, this little, red bits, in RS2, you could it would only show on the side.
Yeah, we changed the color here.
Yeah, as you were changing your cursor. Now you can actually set it up in the channel settings, and you can have a maximum threshold and a minimum threshold. And I think this is really, really good because it gives you a very quick look on how much are we over revving. And this, for the sake of this webinar, I actually lowered the threshold for revline on this one.
Yeah,
it's 500 RPM lower than it actually is, but I just wanted to show what we can do with it. So
exactly, perfect. Let's go to the next slide, and we'll get back to some of these things when we're in the live data. I think there's just some intriguing things here.
A couple thing about this really quickly is also I like to have the on the left side, I like to have my channels as a configuration. I think it's configuration. I forgot what it's called.
You've got them separated out by type. Yeah.
Exactly. Yeah, separated by type, configuration type or something like that.
Yep.
So it's all the ECU channels, all the GPS channels, or all the math channels. I think it makes it very easy.
And let's, if I forget it, remind me, and we'll slide down that bar just to show everybody what that looks like. It's again one of those things that some people want them all together and order them the way they want. Other ones want them broken down by that, or other ones want it in alphabetical order. So again, tons of ways of doing different things inside of Race Studio 3. Okay, let's talk. The way you put together the presentation is kind of interesting to me. You've got basically 3 steps to getting up to speed, and some of the stuff that you focus on, or it might be 4. But so it's just kind of interesting. We're going to walk through some of these, and again, they're just slides, and we'll jump into some live data later. But some of the stuff that you look for as a driver. A rider runs out there and goes onto the track. What's a little bit about what's important about getting up to speed?
Yeah, so let's say you're at the track, it's a new track, or you have a new bike, you have your set of gears, and you have your data system that's installed. The first time, before you start moving, changing your suspensions, before you start touching your gearing, anything, the first thing is you need to be comfortable. So you need to learn the line, you need to have clear inputs as far as throttle and brake pressure, or throttle input and brake pressure. So it's very important to do the work on yourself before you start blaming the bike, or before you start adjusting your equipment. And you're going to start, like, as you're going to pick up speed, your setup is going to change anyway. So there's really no point in chasing setup until you really are nailing your lines and your inputs. So really good indicators are going to be throttle and brake. So for example, and I'll thank Nolan again for sharing his data publicly, because it's a little bit hard for me to share other data. And Nolan is not that bad. This is just, I think it's a cool down lap in the blue trace, but it just shows. So if you have a throttle trace or a brake pressure trace that's very erratic, I mean, you can see that on the blue trace is not staying full throttle. He's rolling off the throttle in some areas. He's somewhat hesitating getting back on the throttle. And his brake pressure is just all over the place. This is really a bad example, but it shows you to extreme of, the yellow line is absolutely perfect. He's getting on the throttle, it's very smooth. His transition from off the gas to brake is perfect. We have the shark fin brake pressure shape that we always talk about. So hard on the brake, trailing out, going back to the throttle. So until you've cleaned up your rider's input, until you've cleaned up your throttle application and your brake application, and your line, which you can see on the right side, there is really no point in chasing setup. So we always start there with our riders. A good example was at Road Atlanta. We started talking about making potential adjustments on the bike and just looked at the data when the bikes came back and parked for me and just saw that, or when the bikes came back, just saw that there was just really no point. They were still learning the track. They were still adapting. So that's my first step as far as the process. So once you're comfortable, once your data is clean, and then once you've learned the track, then we can start moving on to the next step, which is going to be your gearing.
And and you mentioned it real quickly, and I just want to share it again. And I see that Robbie did share it already in the chat box. That Nolan, who has been a previous guest here on our webinars, is a motorcycle racer that makes his data available, and he's a front running rider, and that data, there's a link that you can go to his website, and gives you data from all the different tracks that he's run on over the course of the year. I think the latest right now is still 2021 data. We're in the early part of 2022, obviously. So there's data from 2021. There's a link directly to that page, and it'll be, of course, in the YouTube the description below. So we thank Nolan for sharing a lot of his data from different tracks. So if you want some data from a motorcycle, or you want data from tracks that Moto America visits during the year, that's just a fantastic source of some information you can practice with. So, okay, why gearing matters? There's the we're not going to get deeply into the deep math here or anything, but I thought this was kind of an interesting. It's an interesting phenomenon in bikes when you're racing a bike versus a car. That a lot of folks that use data don't run into this, but it's something that's specific to bikes, and it's how when you roll the bike into a corner or lean the bike into the corner, the rear tire diameter shrinks, and that direct link between RPM and speed tweaks and changes. And you put together just a fantastic slide here for folks that want to understand it a little better visually, and then maybe even do the math with it. And we're going to show you some examples of what it looks like in the data. Talk a little bit about this and why this is important on a bike, what it feels like to you while you're riding the bike, and how that adjusts and changes what you do as far as gearing choices.
Yeah, so on a motorcycle, obviously you have your wheel is linked to your engine by a chain, and that's where you have your gearing. But in a way that's very, very different from a car, your tire is actually round. So although we have wheel speed, most modern bikes have wheel speed sensors on the bike, the speed at which the wheel rotates or at which the center of the wheel rotates is actually not always representative of how much distance you're traveling with that wheel. And so most modern bikes that have a wheel speed sensors also have an IMU, and the IMU gives you, an indication of your lean angle, which is then used to correct your wheel speed then in the ECU and on your tachometer, or on your dash. So you can see I really like this drawing. It's really well done. So it gives you the different dimension of the wheel. So you're going to have your diameter, you're going to have your the width of your tire, and then your circumference. The circumference is really where you start, and that's for one rotation of the wheel, that's the distance you're going to travel, considering that you're not swelling the tire, considering that you're not slipping, and considering a bunch of stuff. But we're just talking about the theory here. Your tire is perfectly round, it's new, and you're straight up and down. This is the distance you're going to, the distance that you're going to do. But then you're going to the third little cartoon. It actually shows that the profile of your tire is really a perfect circle. And as you're changing your lean angle, the diameter or the circumference of your tire actually changes. And it's a direct function of lean angle when you're talking about theory again. So the rear wheel speed, and I have that, I have the two equation here. So we have the zero lean angle. Your rear wheel speed is a direct function of your engine speed, your front sprocket. The rear tire diameter pi 60, which is basically your circumference, and then divided by your rear sprocket, and then there is just 60, and that number, the huge number at the bottom, is just a millimeter to mile conversion. But when the bike is leaned over, then you have to actually start changing that rear diameter function in your equation. So when you do not, when you're going through a corner, I don't know if we have a lot of motorcycle racers in here, but something that's very interesting and something that's very, very prominent at Road America and the carousel, as you're going through the carousel, it's basically a semicircle or even more. You're at full lean angle, and as soon as you start tipping the bike, your RPM shoots up. Yeah, right here. So it almost forces you to short shift before you're getting there, because as you're leaning the bike, you're on the side of your tire, your diameter is smaller or your circumference is smaller, and to keep up, to maintain the same speed, your engine has to rev harder. And you also imagine that there is the momentum of the wheel that's going, and it's basically just adding some tension on the engine. So to keep up, the engine has to rev RPM. And this is why when you're putting the bike on the side of the tire, you really have to start, it's really good to short shift, so you stay in the same RPM range.
Yeah, I was surprised that and we'll see it in the data. I knew that it happened, but I was a little bit surprised at how much the RPM does move compared to the speed. We'll look at it a little bit to show give you a good look at what it looks like in data.
And so if you have, like I mentioned, if you have a newer bike, like most of the 1000s, most of the bikes that are, I would say, post 2015 will have an IMU, and the wheel speed that you see on your data is most of the time corrected, but it's never, like we're going to see in the data, it's actually never perfect. But this is the math that you use if you've ever seen those gearing charts that are just sawtooth. This is the math that is behind trying to estimate which top speed a gearing is going to give you.
But either way, as a rider out on the track, when you roll in there, the RPM is going to come up, and they can correct the number on the speedometer, but it's there's still an action that you feel that you need to understand and why it's doing it, and some ways to work around it to continue to be fast.
Right, there's a transition.
Yeah, perfect. And then we also wanted to kind of share a little bit here the whole concept of gearing. And while we're going to do it around a bike, everybody that's we have a lot of regular listeners here today that may not have a bike, maybe running in a car or a circle track car or something, but the concepts are exactly the same, or even karting, obviously. Talk a little bit about the gearing and because that's what we're talking about here is, okay, we've gone to the track, we've seen some data, we want to make some changes, some things we got to think about, some compromises. Chat a little bit about that.
Yeah, so this one is just kind of the same idea, but just a little bit with a simpler approach. So as far as gearing now, whenever your engine spins, so the front sprocket is going to spin, let's say it has 5 teeth and it spins 3 times, it's going to make the rear spin once. So the little cartoon on the right really shows you, the input versus the output. So the bigger your rear sprocket as a function of your front sprocket, the faster you're going to be spinning your wheel. For one rotation of your front sprocket, you're going to, or for less rotations of your front sprocket, you're going to spin your wheel once. The problem that we run into in really, really big tracks like Road America is that you could max out your RPM and you could reduce your top speed just because your engine does not keep up. At this point, it's just it has to spin so fast for very few rotation of your wheels. So we always talk about, and it was really confusing to me actually at the beginning, we always talk about short gearing and long gearing. So a short gearing is when you have a larger rear sprocket that gives you more torque, so you get more drive, and we call it short because you cannot spend as much time in a gear. You're going to run out of gear basically. And then when you have a smaller rear sprocket, it will provide more top speed, but you usually tend to lose that torque, and that's what you're showing on the right side. And we call that a longer gearing. You're going to be staying longer in your gear when you're on a straight line.
And it's always a balance, right? So you want to accelerate well, obviously, but you also then don't want to run out of speed at the end of a straightaway, right? So there's this, that getting the gearing correct for a track is an important part to balance out the acceleration zones versus the maintaining or being very fast at the end of the longer straightaways.
Right, and so it's a calculation. The other thing that's really interesting in motorcycle is your chain is, you can change the length of your chain, but you can also play with length of chain angle that's going to give you more or less torque, but also more or less just squat and anti-squat is going to affect your geometry of the bike. Let's say you want to go really, really, really tall on the rear, so a large rear sprocket. You are going to have to bring your wheelbase a lot shorter, which is actually going to affect the way the bike is going to flip. So it's just very interesting. It's all about compromises. Then that's why it's really good to play with the front and the rear. So for example, I was at Road America this weekend and I was on stock gearing, which is a 1645. And that was way too short of a gearing. I was running out of gear. I was spinning 6th gear on the straight and really not going that fast. And I'm going back there on Monday. I'm likely going to go to a 1643, which is going to increase my wheelbase and is going to give me more stability because Road America really doesn't turn that much. So those are the consideration when you start thinking about, your rev line, and you know how fast your engine can spin. And by knowing the ratio of your gear, you can actually quickly do the math and see, in theory, considering that you have 100% grip and considering that you're straight up and down, you can know how much, what top speed you're going to be able to reach.
Interesting. The Tice asked the question, that maybe tying it together with some of our folks that are racing that have gearboxes and rearing gears or whatever, final drives. So the sprocket size is more or less the same as a final gear ratio in a gearbox, just much easier to change. And that is a great way to think about it, Tice. It's exactly correct. And and Orkin mentions what you mentioned there, that on the bike there's that whole other third piece, which is probably just as important, if not more, of without changing the length of the chain, you are like you mentioned, Chloe, as well. You're changing the wheelbase, which is a fairly in most forms of motorsports, when you're at the limit, that is a tuning thing, right? It's the length of that wheelbase is important on a bike, even more so because of the forces that are happening the other way too.
We're very fortunate in motorcycle racing that we can make a gearing change at the wall. So it's it's a very good knob, and that's why it's such an important knob that we have to consider when going to a new track. It's really the first step into getting your bike set up. And like we said, because it affects your chassis, because it affects your squat and anti-squat and your bike geometry. If you were to start doing suspension changes beforehand, it would affect your gearing. It would affect like your riding abilities or just your riding in general.
Interesting how it's all tied together. It's we think of it's you go ride your bike at the track, right? But it's everything is so interrelated, and you can get yourself either wrapped, going down the rabbit hole, or and getting confused, or solving a lot of problems quickly if you do it correctly and think it through, right? Interesting. So the other thing you talked about is, okay, so we've just talked about, and we understand now what happens when we change these gears. Now we put it into effect at an individual track, and talk about, you mentioned here on the slide, questions to ask yourself, that there are some things you need to know about the track you're actually running. Talk a little bit about how now you've taken some of the information we've just chatted about and you apply it to track specific things.
Yeah. So the math that we've now learned really is helping us answer the questions that we have here. So the questions to ask yourself whenever you're going to a track, and you don't even have to have ridden a track before. You can just look at a track map and think about, okay, how long are the straights? How big is the elevation change? How many corners do I have? And where's the start finish in relation to the last turn? So how much drive do I really need in order to get through the start finish? Because the last turn is always very, very important. It's even more important when it's in front of a very long straight. So if you take Road America, you can look at it, make your prediction on what your gearing is going to look like. You have that long of a straight. It's a 4.1 mile track, I think. You're going to hit six gear. You're going to be pinned. You want to make sure that you're going to reach six gear pinned by the end of the front straight, just before you roll off the gas, or by the end of the longest straight. It's really good to ask yourself that question again after you've ridden the track. So once you start with the gearing, you go back to the track map. And what we like to ask our riders is, okay, what's your best corner? What's your worst corner? Where is the corner that you absolutely need to be better? Where do you think you can, benefit from passing people, or where do you need, better drive, whatever? Or do you have mechanical limits? For example, running out of gear. What about comfort, for example? Do you have to shift in very odd places? So considering all of that information, considering the geometry of the layout of the track, you can sort of make a good educated guess. And so, for example, if we take Road America here, we have 3 very, very long straights. We have a very high speed corner that's going to shoot your RPM up, as we explained earlier. So those are all conducive to having a long gearing, and you have a long hill just before the start finish, which is your only really big point of compromises. You have the chicane, which you would need a shorter wheelbase, or need more. You need a bike that's more nimble and maybe more drive out of it. But it's one chicane. In the middle, after turn 5, there is a hill, and then you have that long hill before the start finish. These, in my opinion, are not as important as trying to not run out of gear when you're in the long straights. So this is going to give you, just looking at the map, this is going to give you a direction.
Yeah, and it's so variable on different tracks, right? If you had a real tight track that didn't have a long straightaway, or had one long straightaway, then you really got to start to balance. Okay, yeah, I'm at the maximum revs at the end of the long straightaway, but maybe I let it be, because I get so much more performance in some of the shorter acceleration zones and some of the shorter straightaways and such. So something to think about, something you need to think about.
Absolutely. And yeah, for Road America, it was very, very straightforward. If you take a track maybe more like New Jersey. New Jersey is a much, much tighter track, does not have that long of a straight line. And in that case, you're going to want the bike to flip better, you want a better drive out of the corner. And then you have tracks that are kind of interesting, like Brainerd. Brainerd is basically a roval. The turn 1, turn 2 is a very, very, very long. It's not a straight, but it's basically like Daytona, right? It's a little bit banked. It's very, very fast corner. But the rest of the track is very tight. So in those cases, you're going to have to make even bigger compromises.
Perfect. And then I think maybe it's one of the last points you were making here, but consider your shifting points, the actual places where you're actually shifting. Now you've kind of settled on the gears, at least for a moment, the right sprocket choices and such. Now you've got some different choices that you as a rider can input differently while out on the track. Talk about that a little bit.
Yeah, so this is now looking at the data when you're actually chasing gearing. These are all of the hints that you can find. So the question to ask yourself again, or where am I shifting? Am I shifting in areas where I feel comfortable? Sometimes you don't want to be shifting when you're leaning on your left side, because it's really hard to put your foot under the shifting peg or shifting lever. Or are you using all the gears? If you're at the straight line at Road America and you're not hitting 6 gear, or you're hitting 6 gear but you're not using all of it, then there is more to be had. Where are you reaching your top speed, or where are you reaching your rev limits in 6 gear? So all of that are the considerations. And so, for example, looking at that first rider input, looking at Nolan's data, we see that he's upshifting every single time when the bike is close to red line. So this is perfect. He's using all of his gears, from, I think it's about maybe 8,000 RPM to 16,000, which is the range at which the R6 is really efficient. The downshifting is obviously needed whenever you're slowing down or when you need more torque. So if you need to have a good drive out of the corner, this is when you're going to downshift. And, I'm talking about the notion of torque here. At some point, your torque, at some RPM, your torque is always going to go down a little bit. Every torque curve has this point where it falls down. So there's really no point in going into the red line and thinking that you're going to have more horsepower, going, or more torque going, full pin. So you're going to upshift at the rev line, and you're going to downshift when you need to slow down. So knowing those basic principles, you're looking at your data and you're thinking, okay, front straight, for example, he's shifting to, we can't actually see, and we'll see on the live data, he's shifting to 6th gear early enough that he can carry all of it up to the slowing down point in turn 1 at Road America. And you can see that he's hitting the rev line just before he has to slow down. So this is a really good point. Then when we talk about compromises, if we look into, so it's turn 5 going into turn 6, there's this hill. He has a very short excursion into 3rd gear. And so because it's going up the hill, so he needs that drive. When you're looking at that, you're like, okay, well, it's okay. He has to shift and then downshift right away. It's kind of a waste of time, but he needs, like, he gets the drive, he needs the power to go up the hill, and it needs to downshift right away. Well, whatever. I mean, this is part of the compromise. It's okay. We're going to use this. It's an area where it's not too hard to shift. Well, okay. We'll leave it there. And, it's never going to be perfect. But those are the considerations. Basically, maximize the use of your gears, minimize the inconvenience. Basically.
Bruce asked a question in the question and answer that talks about, we've talked about the external gearing, right? In Moto America, are you allowed to change the inside, the inner, for 1 through 6 gear ratios for specific tracks, or do you have to leave those stock?
It depends on, I think it depends on the class. Twins, we're not allowed.
Okay.
On Super Sport, which is what Nolan was writing, it's not allowed either. Superbike, maybe.
So that and what you showed here was, you can get all of this perfect in the important areas, the best you can do, but there may well be some spots where this is just imperfect, right? You're having to do a quick upshift and then another, and then right back down, and that's part of the balancing, the compromise of getting everything else right. If you were allowed to change your internal transmission gear ratios, if this is 3rd gear, you might be able to throw a little longer 2nd gear in there where you could have ran that one all the way up there or something. But it's pretty in depth at that point.
And that's a cool preview on where we're going to talk at some point in with the math channels. Now RS3 has the ability to have lookup tables. So I use the lookup tables to look into. So the lookup tables knows which gear you're in. It actually knows, because of the table that you input, it knows the gear ratio. From knowing the gear ratio, your tire circumference, you can actually calculate the wheel speed, or the theoretical wheel speed. Having those lookup tables, you could have different lookup tables for different transmission. You could take a lap and just overlay what the effective transmission would be. And it's really cool. I mean, we can do that on Excel. I have a file that does that on Excel, which is really cool. But it's pretty simple math. It shows you the effect of gearing, and it won't tell you exactly where to shift, but it will tell you if you were to keep the same shifting point, this is how it would affect it.
And the lookup tables will be part of an upcoming webinar. We're going to talk about preview a little bit to our upcoming next webinar, but practical math channels is next week, and lookup tables will no doubt be mentioned there. Probably not to the detail of what you just went into, how to use them deeply, but we'll talk about lookup tables and where some of the power of what they do for you will be happening.
Yeah, and Carol is mentioning that gearing gets more interesting when you start pulling some arrow. Yeah, your shifting points are also going to change if you're getting into the draft. So, and your top speed is also going to change if you're in draft. So there's just so many, it's really, really hard to model a motorcycle tire. I actually don't know if Formula One or, IndyCar, very advanced car racing series do tire modeling. I would imagine they do. But it would be really cool. My next step would be to have TPMS sensors, and I'm working on it, Matt. Have TPMS, so then we can estimate, the change in pressure, the change in temperature, and I don't know if there is a relation between tire degradation and time and temperature, but those would be also really, really cool thing, and torque applied to the wheel. So there's a lot that can be done.
Yeah, a lot of tire modeling is done, but I think they do it more for the simulation pre-race, kind of thought process. Where on a bike, it's almost the roundness of the tire and some other things. It may be something you could use in real time. So, your fourth step is okay. We've walked through some steps on how to understand the track and the gearing and then making compromises around. Well, the last thing is adjust your gearing and go out and have some fun, right?
Yeah, absolutely. And you may like a gearing, and that's not in theory what we would suggest, because you're more comfortable. You could have a very short gearing that would lead to a power wheelie like Jason here, and that's annoying. So there's a lot more into consideration. It's not an exact science because of just the way that the tire and the chain angle affect everything. But yeah, just go out there, change it, talk to your team, have another tire, another wheel with another sprocket on it, and just make a quick change at the wall if you have the ability to do it, and gather some more data.
You say annoying, but to me that looks like it'd be quite a bit of fun. Maybe not the fastest way around, having to fight that all the way, but that does look like it'd be a lot of fun, though.
Not a lot of fun.
Okay, let's bring up Race Studio 3 real quickly and go over a few things. We got about 10 minutes of scanning through just a little bit of this. I think we chatted about 3 or 4 things that I wanted to cover real quickly, and one of them was this braking sensor data here, where we have it inverted, where it's dropping down and being virtually connected to the throttle position. And the way that we do that, there's 2 or 3 ways, but the way that I tend to do it is if you open up the channel properties for the channel of brake pressure. It's always, you hover over the channel, you'll get this little cogged wheel here. It'll open up the channel properties, and if you can open this box by itself, but if you do it by the channel, it opens up and makes that channel active, which is kind of handy. And then what I've done here is you use this modification box. And this box can do several different things. Number one, it can just give it's a scale or a shift, right? A is a scale. Every value that truly came in is going to be multiplied by the number that you plug in there. B is a shift. It's just going to add that number. So if you've got a throttle position that shows 105%, you could go into that channel, subtract 5 off of it, and then you'd be hitting the 100% in the data side of the analysis side, right? But in this case, the standard number in 1 by default is a 1. We take whatever channel comes out of your ECU or your sensor or whatever, and we don't touch it in Race Studio 3. We just leave it alone. By putting a -1 in there, you're taking the inverse of the channel, right? In effect. And then, of course, when you do that, now you flip the channel, so you're going to have to consider your scaling. And in my case here, we didn't want zeroed. We didn't want this red line bumping up here where you could see it all the time. So I went ahead and just said minus 50. So that red line is actually up here. The 0 line is up here kind of underneath the throttle line. So if I had to put that at 0, we'd see that red line of the 0 brake pressure. But put it to minus 50 and then find the peak and go a little bit farther. Peak is about 250 or so, so minus 300, and boom, you've got your brake channel flipped in the way that is so kind of interesting to look at here. So very, very cool. Very cool.
So you mentioned something that was really interesting earlier. You mentioned coasting. So the fact that we have throttle and brake going a continuous line like this shows us data or shows us indications of coasting. I believe that now I created a math channel, but I think there is one that's already in the template. So if you go to the math channel tab, you can actually see, I gotta move that stuff. There is a coasting. GPS coasting on. So the GPS coasting on is based on GPS TPS. Well, you have to
build some other channels to make it work.
All of them. They're all integrated, but basically it's taking your lateral acceleration and your longitude and your lateral deceleration, basically, or negative, to say when you're braking and when you're on the throttle. But you can reproduce the same channel, not based on the GPS, but based on your TPS and your brake pressure. So you decide what your threshold is for brake pressure activation. You decide what your threshold is for throttle activation. And every time that you're not between those ranges, you're coasting, and you can have just like a flip, basically.
I would be very, very surprised if we don't discuss that exact topic and adjusting those values in next week's webinar. So perfect, but this is a visual representation of a rider that is coming off throttle and going right to brake pressure, right? So we can see it visually. What we can't do is do math on the time that the driver did. And I'm just going to zoom in on this one right here, just because visually I see that there's a disconnect between those two lines. That is what we're looking for, right? That is tiny, and it's not and it's in the middle of a corner. So he's waiting on. You can see by the lean angle here, and he's coming down, right here at the apex speed of the RPM and the speed and full lean over. Of course, he's going to pause there just for a little bit and then take off. Not saying you should never do that, but that's visually what you can see, and then that would focus you into an area where to go look a little harder. So,
and then when we're talking about weird things in the data that makes you want to have a smarty cam is, so going back on the throttle, he's pausing a little bit and then going back on it. Right here, probably 80 to 100, there's a little pause. Those are
right here. Yeah, right here. Yep. So you'd wonder what happened, where it happened, why did it happen, right? We see that something happened, and now we see that it's right when he's pretty much at full lean, but he's accelerating pretty hard coming off the corner. We know that it's down here in turn 2. We can zoom in and see a little bit of that. The why is what is a little harder to get to. A go-to for you in this case would be great to have that video playing right over here and understanding, was there somebody in front of him, whatever those kind of things, right? So perfect. Do
you want to go to the electronics so we can talk about the wheel speed?
You've got some tabs here built, and again, we've only got 3 or 4 minutes, but this user profile is available to you if you want to download and link. It'll be, if you're watching it later in YouTube, just click on, there's a user profile zipped up file you can grab and load this onto your computer. But and she has time, distance, track, split report, electronics, and GPS. She has another one that's kind of another way of looking at it. She calls it electronics on the tab. Talk about what you're showing here and how you use it a little bit differently.
Okay, so on this I have my front wheel speed, my rear wheel speed on top of each other. I have my ECU channels for the grip position, as well as how the throttle actually moves, the throttle plates. I have my RPM, my gears, and then it really depends on what type of bike I'm working with. Some of them will have traction control intervention or wheelie control intervention or some IMU stuff. This is basically what we have with the R6. I think it's the YEC kit. It's really good to have. You can somewhat reverse engineer or understand how how the bike strategy or the ECU strategy is intervening. For example, by seeing, and those might not be perfectly aligned, but you can see that even though you're completely opening the throttle really fast, your plate might be like the way your throttle plate is intervening might be a little bit smoother.
Yeah,
so these are right. These are throttle progressivity. There could be modes. There could be riding modes. So if you're in engine map 1, 2, 3, you know, that could be what it is. As far as wheel speed, I was talking about how the ECU is always correcting for wheel speed, for lean angle. You don't see that all the time. So for example, here going down, so in sector 5, going down the hill, there is the wheel speed on the rear side completely drops. And so if you go just a little bit further, right before 6,
right in this area?
Yeah, the wheel speed drops. So you're thinking that he's going down the hill at this point. The front is loaded, he's on the brakes, the rear wheel is probably sliding a little bit. There's something going on here. Maybe it's and when I'm saying sliding, it's not spinning, it's just like stop spinning because all the weight is on the front. We can also look at the effect of lean angle. I think you had it, Roger. I think it was a little bit further, maybe in the carousel. Or I think it was on the back straight leading to Canada corner. There is a kink, and we could see that the wheel speed was actually shooting up. Yeah, right here. I need to move my thing to see where it is. Yeah. So this is the kink leading into Canada corner. He's full throttle or running, you know, rolling off the throttle a little bit because there is a kink. But this is weird because his wheel speed increases, and it increases because he's leaning, and you can see right down at the lean angle on the blue channel. He's leaning the bike just a little bit, that, you know, it shoots his wheel speed up.
Yep, that rear wheel speed up, and the one RPM. Yeah, and the RPM is does some odd things as well. And there was one spot that I was able to see, and I think it was trying to capture it in my mind.
You have a little wheelie also. Well, we've talked about that before.
Yeah.
In 11.
Yeah, exactly. The brown drops down just a little bit. The front wheel speed drops down a little bit. So all stuff that you can kind of see in the data. It's kind of interesting. The one other question that came up earlier was the order of these channels. I wanted to make sure we covered that before we kind of take these last couple of questions real quickly. If you want to change the order of these, right now, the way you have it set up, what you like is this is the channels that are coming from the logger itself. This happens to be Evo 5 data. And then if you scroll down, you're going to see that it is split then into the ECU channels. They're all grouped based on the configuration of the different pieces of units, right? Some calculated channels. Those are, in other words, GPS channels in our world, the way that we look at it. And then there was some math channels that were added as well. That bike lean angle here is a math channel. In this particular case, some of the bikes have that lean angle built into the ECU. So and that's changeable by coming up and clicking on this sort type. You can click on this and you can sort by the configuration, which is what we're looking at there, I believe. Sort alphabetically, sort by the channel type, I think is actually what we're doing here. Yep. And then a custom sort, where it brings up a list and you can put them in the order that you want. So this is a little different than many people use. They just leave it in the standard, alphabetical order. So it's but whatever works for you, right?
And Matt asked, I wonder what causes the TPS dip. We're at.
Probably right here at the end. There's a couple of them that are that look a little bit. That could be the rider. It just, since both are doing it, my guess is the rider just relaxed just for a second there, But hard to tell. Hard to tell.
When up and down, that's interesting. Maybe he just rolled off because of the rev line. Maybe it was just like
Yeah, who knows for sure. Something that your eye should have caught, and you, if you were the writer or the data person, the engineer, you would say, if maybe focus on that a little bit, keep that full throttle, and make sure it's not the rider doing it, right?
Right.
So, perfect. Somebody answered that one. Chloe, do you use the gear channel shape or other for spooling wheels For spooling wheels up info, for understanding wheels up info.
Let me
Use the
just
channel,
look into
your
it.
channel shape or other for spooling wheels
The gear channel shape.
info.
I'm not sure I understand it completely.
No, I think it's for wheelies, and there's some other ways of doing that with suspension pots and of course the wheel speeds. You've talked about that in previous webinars a little bit. So Bridget mentions, would a potential be there to look at if he needs to turn in a little later to be able to consistently build that throttle? There's a data analysis, deeper data analysis thing, and I think what you were talking about was, we looked at that one area right here is what Bridget is mentioning, I'm sure, where he had to hold throttle for just a little bit where he was at in that corner. And you're very well right. Maybe it's position, maybe it was another bike in front of him, maybe it was any number of things it could have been. I would definitely look deeper into the data to figure out how to get around that.
What I really like to use for this is a split time report. I actually, last year I had made a little code that would put together the best sectors, but now the split time report is actually doing it, where you can look at a sector and you can see how a corner is being approached, and you can see GPS speed through it. You can see, so it compares all of the GPS speed for just one little sector, and you can highlight it. So you can, and right next to it, you have all of your best split times. So it's really cool because you can actually see which split time was faster and what GPS curve you actually had. So you can, it really indicates, if you map that with the GPS line, it really tells you what's the best way to take a corner.
Bottom line is, this is a critical area. This is the second fastest straightaway on the track, and is hesitation on getting to full throttle. The first thing I would do is I would go into the laps and I would just pick a second lap, and he does it again, right?
Look how the wheel, the rear wheel speed is increasing. He's probably sliding.
Yeah, could be spinning the tire a little bit at that point, right? Yep. And I would look at multiple laps, and it's a consistent problem. Okay, now we take the next step. Okay, why is this happening? It wasn't just that one lap.
Yeah, and he's at full lean, so he's most likely spinning the tire.
Yep, and needs to wait, which means he could back the corner up a little bit and maybe get to the point where he's opening up, or changing the radius, diamonding it off a little bit more, all sorts of different things. So, but that's part of the data analysis and the driver coaching part of it, right? Perfect. Anything else inside the data that you wanted to chat about before we jump back out?
Matt wants to do some wheelies at 150 miles per hour.
Don't we all? Don't we all? Okay, let's jump back out to the PowerPoint. We're just a couple of minutes late, not terrible. And there are some other resources that are available that Chloe has put together a slide on. Chloe, talk a little bit about these 4 options for folks before we kind of close this one out.
So Data MC is a really, really, really good resource for data analysis when you want to get into it by yourself. It has a list of math channels, all in AIM format on RS2, so you'll have to adapt it. Those little cartoons that I took with the equations are from there.
Oh,
it has some Excel sheets with templates where you can put your data in it, and it can run some calculations for you. So really, really good resource to start getting into data. And it's specific for motorcycles. Gearing Commander has a library of stock transmissions and non-stock transmissions. So you can start simulating. If you don't want to get into all those calculations that I mentioned, this is actually a good GUI to do it, or a good interface to do it. So you can see the effect of different transmission ratio, different gearing ratio, different wheel sizes or tire sizes, and then there's a chart that shows you, for a certain RPM what your maximum speed is going to be in all the different gears. So if you don't want to build your own math channels, this is a very, very quick tool to use. I like it. Then motorcycle dynamics is just I always have it here. It's way more advanced. Has a lot of. It's probably the only really good reference that we have as far as dynamics and chassis setup and chassis calculations that's been done so far by Vittorio Cosalter. And then the racing motorcycle is maybe a simpler version of it. So Racing Motorcycle has, this one is a volume number 3, has an introduction to chassis setup. So very good overview of suspension, chassis, effective gearing, all of that. And that's actually, I would like to show it to you. My computer is resting on it right now. It's actually a pretty big book, but very well illustrated, very well explained. I like it a lot.
Very good. Couple of great resources there for folks if you want to learn a little bit more about the dynamic side of it. Perfect. Let's kind of wrap this one up. This video, well, as soon as we finish, it takes me a little bit of time to work through the YouTube world and get the video ready and up there available, but it'll be up on our YouTube site very, very shortly. It joins, it's number 210 that we have up there, so we have quite a few, and review some of the different ones. Chloe had the 3 previous webinars, they're all out there as well, so if you just do a quick search for her name, you'll find them, and you'll be off and running. Love to have all that material up there, just a vast library of information from a lot of really, really good people that come and join us. The customer support, of which Chloe is often one of them, out there working and helping folks understand their hardware, their software, and get the most out of the systems. And we really appreciate it. And if you don't see us out at the track, there's an 800 number there for you to call and ask us any questions and allow us to help you get the most value out of these pieces. So, next webinar. Practical use of RayStudio 3 math channel functions. A couple of things that Chloe discussed today will no doubt be in there. The tables and the core set of channels that are available for you and how to modify those. She talked about the coasting channels. No doubt we'll talk about that in this webinar. I'll have Emiliano joining us from Italy, the head of the software team that wrote this, and Matt will also be joining us, who's here in the as a participant here today. Because Matt has been heavily using them. One of the pioneers and early adopters and has been using math channels pretty hard here for the last couple of months. So we're going to talk with him about some of the more practical uses and some of the tips and tricks that he has found and things that he can help the rest of us learn as we go. So that will be next week with a week from today on Tuesday. A little bit of contact information. Chloe has been great joining us here for now her 4th webinar, and this is part of what she does, and she's out there helping a lot of folks. There's some contact information, not only your email address, but also a couple of different Instagram accounts. Tell us a little bit about those and what you do on your Instagram.
So I have 2 Instagrams. I have my personal one that is basically all about motorcycles and just like day-to-day life of things activities that I do. And then I have the Unicornium engineering one that's very centered on data and also very centered on my motorcycle project, where I call it Robbie calls it the Frankencycle. I call it the Catfish, because it is a 2008 motorcycle that kind of looks like a 17, in which I'm trying to incorporate an MXS 1.2. And it's all the trial and tribulations of trying to do something that nobody has done before. It's quite the adventure. I went to the track for the very first time with the MXS on it, and although I do not have all the channels I would like to have right now, it is incredible. I really, really like it. Having the dash screaming at me that I'm too slow is
frustrating at times, but very realistic and very valuable. And I'm glad you have Robbie helping you work through some of the ECU connections and some of the other things, I'm sure. So you've got a lot of support there to help you. And the more you learn, the more that you're going to be able to share with other people that walk behind you doing the same kind of a thing.
I know that Robbie is very, very busy, but if you have any problem, just hit him up. Just make him more busy.
There you go.
Robbie,
there
thank
you
you
go.
so much. It's been great.
Appreciate it. Well, thanks everybody for coming. There's some contact information. We thank you, Chloe, for coming and doing this with us again. We want to do as many motorcycle focused webinars because it's such a huge group of users of ours, and we want to make sure that we're not neglecting them and giving them the information they need. Hopefully, if you're watching this and you're a motorcycle racer, there is again in the list down below on YouTube, there will be a long list of the last 8 or 10 webinars that we did that are specific functional discussions of every function. If you want to know more about the channel reports or the GPS tab or the time compare bar, we don't talk any about specific types of motorsports using them. It's the function, how to make that function work the best for you. So go review some of those. That'll help you a lot. And then some of these motorcycle specific ones where we talk about certain things will hopefully be helpful as well. Chloe, thanks again for coming. I sure appreciate it. Look forward to doing another one. We've already got her on the schedule for a couple more leading up. I think it's about 5 or 6 weeks out where we're going to have a chat. So looking forward to your next one. Thanks for coming, Chloe. I sure appreciate it.
Thank you. And I'll see everybody in the motorcycle world at Road America this weekend.
Not much of a better place can you find for a motorcycle than Road America. So thanks everybody for coming, and we will see you all next week. Talk to you soon.
Right. See you guys.